Hi, in this video I'm going to build and test a variable speed clock. Now I do something really stupid in this video. It's probably going to come back and actually haunt me a little bit. Specifically, I might have hurt a chip, so keep an eye out for that.
Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey.
Hello, this is a 555 timer. It is used to control all kinds of timing circuits. And we're going to use something similar to this for our clock module. Ben Eater did an excellent video series on the 555 timer and how to get that working. And I do highly suggest that you go watch that. I'll put links in the description. Now this will generate the clock cycle that we can use for our computer. I'm going to want some kind of an indicator LED to show when the clock is happening. We're probably going to want an inverted version of that as well. And then of course I want to have some kind of an indicator on the clock to show. I want to be able to switch between the automatic clock and manual stepping. And so for the manual step, I'm going to want some kind of an indicator to show that. And then on the switch, I'll want something to indicate whether or not I'm in run mode or in single step mode. Ben Eater uses a 555 timer to debounce both the switch selecting run mode and single step mode and the single step button to debounce those two circuits. And then some kind of an inverter to indicate, to basically flip the clock signal. And then there's some kind of an indicator that indicates whether we're in run mode or, in Ben Eater's case, whether the CPU has been halted. I don't believe that we need to debounce this switch, because the use case for this is not that I am running it up until a certain point and then want to stop it. The use case is I want to stop, reset the computer, and then run a specific test. So I don't think we need to actually debounce that switch. Now that leaves two 555 timers, and I have here a 556. Now, it's not that the 556 is one better than the 555. What it has is two 555 timers built onto a single IC, a single package. Moreover, the 555 has power and ground, specifically ground, in a different spot than any of the logic chips that we're going to use. And I believe that's going to create, it may create some confusion if you're not used to that. So the 556 has power and ground, specifically ground in the traditional locations for the logic ICs. That is, power is up here on the last pin, and ground is down here on the far right pin here. And then now we've got a lot of LEDs, and I don't know about anybody else, but I'm pretty heavy-handed. I've got big old club hands, and sometimes it's difficult getting in there. So I want to replace all of those LEDs with this LED graph. Now, this LED graph has, grabbing a pointing device here, it has one red, one yellow, and 8 green. So I will try to zoom in for you, see if I can actually get that to a portion of the screen here. That's as far in as it'll go. So it has one red, one yellow, 8 green lights. And I'm not tied to any particular color for any of this. So that being said, I can replace those 6 LEDs with these 10. And ultimately it'll end up being a little bit more secure in my breadboard. Then I've got all the passive components, the capacitors, the resistors, and I do have a variable resistor that I'm going to tie into this. This is a 1 million ohm or 1 mega ohm resistor, variable resistor that I'm going to tie in. Hopefully I can get these to spin a little bit easier. They're a little tight. But this will be used to control the speed of the actual timer. So this is going to be associated with that component or that signal. So that said, let's see what we can do to get this on our breadboard. Okay, so here's a breadboard. And I usually orient these with the lugs pointing down. And the reason I do that is twofold. One, it puts the ground close to the ground pin on the ICs and the power close to the power pin on the ICs. Therefore, I don't have to go very far with those. It's also numbered from left to right. These are the busboard BB830. They're a little bit more expensive, but I found actually if you buy 2 of them as a BB1660, you can easily separate them apart. They are actually 2 individual boards that are lugged together, and they're actually less expensive that way. Notice the power rails up here are connected. These lines go all the way through, so once I get power in them, the entire rail is connected. Not all of them have that. And then I want to stick power and ground in here so that I connect the 2 rails together. I don't want to be dealing with not having power and not having ground on that and then try to troubleshoot something silly like that. So now we've got the placement of our controls, and I'm going to do this based on how I want to be able to control things. I'm right-handed, and if I'm going to be doing anything, I'm probably going to be reaching over and pushing that button. So I want it relatively close to the edge. I want it easily accessible. Next to that, I think I'm going to stick my potentiometer, which will allow me to control speed. Now, as I mentioned before, this one's tight. It doesn't spin very easily. I'm not a huge fan of it, but I don't have much of a choice in that. Not sure how I can free that up to work any better. And then I've got the switch that's going to switch back and forth between the 2 of those. Now, these don't properly line up in the breadboard, but I found that if I actually use a little bit of encouragement, it will go in the right direction. So I could stick those there and have this up here. Yep, that's as far back as it'll go. So I could stick this here and have the speed control up here and my push button here for single stepping, and then that puts everything all in the same spot on the right hand side of the board where I'm going to be spending most of my time. This is the LED, and this sets up just like a dip, and it's very easy then to identify what's going on here, or light those up. Not sure where I want to put those. This is the 556, and then this is the inverter. I'm going to double check that and see. That's incorrect. I have them backwards. So that's the inverter. This is the 556. So, nope. So these pins, as you can tell, are splayed out. And so I have to kind of roll them to put them back into place so they point straight down and fit into the breadboard nicely. Okay, and then my inverter. Now, keep in mind, I also want to put the power monitor over here. It doesn't take too much space, so I should be able to get that fit over here without a problem. Now, the challenge is going to be routing the signals from this push button back up over here, and maybe I want to switch these two so that my indicators are over here a little bit better. Now, what I have not done is I have not pre-wired any of this to figure out what things are going to do and what the best way to do it is. So I may end up changing this all, and it may not end up working out well. What I did do ahead of time, put them down here, what I did do ahead of time is cut a couple of these small wires, and I will probably do that more often than not, just to save a little bit of time. These allow me to wire up power and ground very quickly. So ground being here, it's just a short jump. And ground being over here. And this one is not lined up with a hole, so we'll stretch it out a little bit. And power being up here. And up here. Again, not lined up. Boy, I planned well. Let's do this. Move those over one. I'm going to take this 555 and move it over one. Or 556, excuse me. And then that should give me the ability to pull this one out and drop it in here. And have that work a little bit better. Alright. Now I got to figure out exactly how I want to wire this up. The documentation for the 556 has two circuits. Both of them we're actually going to use. One of them is astable operation. Astable meaning, A meaning not. Astable operation meaning not stable, meaning it's going to bounce back and forth between two states. And then monostable operation, meaning it is going to be stable in one state. And then when you trigger it to do something, which is the input here towards the trigger pin, when you trigger it to do something, it's going to do something for a period of time and then go from its unstable state back to its stable state. So that's going to be the single pulse. And so we want to make sure that that single pulse, when I push that button, holds high for a period of time, so that I can keep an eye on things as I'm trying to debug. So that tells me how to wire things up. What it doesn't tell me is what the values of RA, RB, and capacitor C need to be. This RL that's here is the load. We're not going to be connecting that because we're going to have ICs downstream from that. That'll be the load. So I think I'm going to work on the normal clock first and see if I can get some kind of a signal out of that. So I need two resistors for that. RA and RB. RB, switching back overhead, RB is really going to be this resistor right here. That's the variable resistor. So that's going to be the one that controls the speed of the clock, or the frequency of the clock. RA, on the other hand, is going to control the amount of time it, or actually add to the amount of time it takes to bring the circuit high. Brain fart. And I'm looking at this and I'm seeing that there's no pins associated with each of these. So I actually have to bring up a copy of this side by side with the pin configuration so that I can actually see what I'm doing. Okay, that took a minute. So, reset we want to tie high. And reset for the clock, I'm going to use the top up here for the normal clock operation. So this is going to be the one that actually ticks automatically. So that's going to be pins 8 through 14, and reset, which is pin 10, needs to be tied high. So this is pin 8, 9, 10 needs to be tied high. Okay. The control, which is right next to it, pin 11, there's a note here that says we should add some kind of capacitor to that to improve operations. And from my experience, that's not a bad idea to do. So I'm going to add a 0.01 microfarad capacitor. I just happen to have one ready from an old project. Tying this to ground. And so that's pin 11, which should tie that to ground. So once again, that's pin 11. Threshold and trigger should be tied together. So threshold being pin 12 and trigger being pin 8. Switch view back again. Pin 8 is trigger. Pin 12 is threshold. Now, if you have done any work with the 555 timers in the past, this is the wire that wraps around the entire chip that everybody has to put in place, or sometimes people route them over the top. Okay. So now I've got to figure out some capacitors and some resistors. From VCC, I need to come into a resistor, which is going to be connected to the discharge. Now this needs to be a relatively small resistor because you don't want it to skew the charge time so that you have a longer time high than you do low, significantly anyway. So this is going to be discharge. Discharge is pin 13. And so that's, I'm going to switch back to my documentation here. Discharge, it's going to come through resistor A up to 5 volts. Resistor A in my setup here is going to be a 220 volt resistor, or 220 ohm resistor. And I happen to have them cut, so I'm choosing that right now until we can get things dialed in the way we want them. So that's going to go from 5 volts to pin 13. So 5 volts to pin 13. Okay. Then I need to go from pin 13 to my variable resistor. So pin 13 to my variable resistor, and that is way too tight. Let me grab a different. So pin 13 to my variable resistor. And I'm going to stick it in the one side here. And then from the variable resistor, I'm going to go back to either threshold or discharge. I'm sorry, threshold or trigger. Let me switch back to my view here. So I've got this resistor wired up. I've got this resistor wired up to this point, and I now need to make this connection. So I'm going to take the center tap of my variable resistor, and I'm going to drop it right here where the trigger is. Those two are bound together. And then, so all three, if I look at this, the center tap here on my variable resistor and my threshold and my trigger are all one node if you think about it in electronic terms, meaning that these are all bound together. Theoretically, they're all the same connection. And then I need a resistor, or I'm sorry, capacitor back to ground from that connection. Back to here. I need a capacitor that goes from there back to ground. And I'm going to try a 0.1 microfarad capacitor. So theoretically, this here should go back to ground. And that should be all the wiring that's necessary to get some output. So I'm going to take another 220 ohm resistor, and I'm just going to pick this far right LED for now. And let's see if we can get something to actually happen. So, connecting to ground. Just going to double check and make sure it lights. It does. That's a red LED. But when I plug these in here, theoretically I should be flashing. But I have not connected my output yet. My output is on pin 9. So I'm going to pick up pin 9. Pick up pin 9 and plug it in here. And that's not doing anything. But if I connect there, I do have something. So, what is not right? Reset is tied high. Maybe my resistance is too. There we go. I really don't like this thing. I'm just making sure that chip's not heating up, but when I disconnect that, it should be going out, and it's not. Okay. Well, let's unplug that and troubleshoot. What I think I might do is use my other clock timer as a reference. And I'm going to check my work against that. Okay. So, this is modeled after Ben Eater's 8-bit computer. And I tried to expand this to 16 bits and had marginal success with it. I do have some problems that need to be sorted out. So that said, I do know that the clock works. And I do know that I have both a 555 and a 556 timer on this particular circuit. Now I can plug this in and demonstrate that the clock actually does work. And you can see I've got it dialed way down very slow. And this is similar to what I'm trying to duplicate on the other one. This is the circuit here that performs the clock, the automatic clock pulse. And so what I'm trying to do here is figure out what I have where. So pin 2, which should be threshold, has a much larger capacitor on it. This is a 1 microfarad capacitor. Put this back in. So let me grab one of those. So it might have been working. It might have just been clocked really, really fast. So I'm plugging that in down here. Let's into view here. Okay. Still no change in behavior. So the other one is I'm looking at this resistor here, a brown, black, red. I believe that's 103, 102. So it's a 1000 ohm resistor there. I put in a 220. So let me take this resistor out. And that's tied to power. And put in a 1000 ohm resistor. Now, to be clear, this analog electronics stuff is sometimes a little lost on me. And then I have another resistor that's buried in here, another 1000 ohm resistor that basically sits in this line right here. So if I do that, I could move this over to here and tie in here. Now watch, I'm putting it in the wrong spot. So I now need to move this over 1 to here. Let's try that. No. This capacitor going to ground is a 103. This one is a 103. goes to the left. The only thing I can do is plug this in here, but I don't believe that's going to create a difference. And I broke my wire harness here. That's the same size variable resistor. Alright, time to get the scope out. Okay, I have the scope out. I'm going to try to do this without getting too much glare. Zoom out just a hair more. So I've got my scope propped up on the back of my wire strippers here. As I grab the probe, I'll plug this into ground here. And then I want to probe this signal here. Well, that signal is what's turning on the LED. And you can see I'm not getting a whole lot of movement here. Let's see here. Try that. That works. Let's see if I can slow this down or speed it up. And that is 10 nanoseconds per division. Slow it down. And you can see it's just not doing anything. So I am not cycling. This chip is not getting hot, so it's not doing what it's supposed to be doing. Okay. It's showing 3.8 volts. VCC discharge. It should be wired into the front end of the resistor, and threshold trigger should be wired into the other side of the resistor. Why don't we take and eliminate the variable resistor. And plug in a really long 2 million ohm resistor here. Just to see. If we can get any kind of, still 1.93 volts. put my other capacitor back. So capacitor should be off of trigger threshold to ground. Nothing. I'm gonna go look at my 0.01 microfarad. To ground. Yep, I am stumped. Okay, this is embarrassing. I picked it up and looked at the chips, and you guys probably all caught this but me. But I managed to wire up my inverter as if it was the 555 timer. Well, that ain't gonna produce squat, and I probably hurt the inverter at the same time. So let's move some stuff back here, get it back into the right spot. I've got power disconnected now, so that's going to go back to here. This one will come back over here to that tap. And now I want to take all this 2 meg resistor can go away. And I'm going to take all of this stuff and relocate it down to the 555. So here's my capacitor. And then this is also on pin 8. It comes down. Pin 9 is my output, so that's going to move there. Pin 10 is tied high, so I'm going to move pin 10 down here and still tie it high. Big old club hands. Pin 11 has this capacitor on it. Again, that's tied to ground. Y'all are probably screaming at the screen. Oops, let's move that over one. Give it just enough room so that it can do that. Now, again, let's hope I didn't hurt the inverter. But this now gives me the ability to watch it flash. And then if I turn to the right, it should speed up. And now it's flashing so fast that you can't actually see it. And the frame rate on the video is such that it looks like it's coming in and out, but it's really flashing at a consistent rate. That's turned all the way up. And that's turned all the way down. Okay. Well, that's bloody brilliant. Embarrassing as hell, too. So I'm going to spend a few minutes, and you guys will have to tell me if you want to watch this or see it go by at speed. But I'm going to spend a minute or two trying to clean this up. Actually, what I'm going to do is I'm going to flip this around. And I'm going to tie this to ground down here. By doing so, I'll make it a little bit easier. First, I'm using a green light instead of a red light, and I make it a little bit easier because it's all up on the top side of the top side of the chip there. Top side of the breadboard. I'm gonna have to figure out how to actually think and talk at the same time. I don't do that well, apparently. Okay, but I'm gonna do some cleanup. I think on this one I'm gonna go ahead and do the cleanup and probably hit fast forward as I go through it. And you can tell me if you like that kind of a format or if you would prefer me just snap my fingers and say, okay, it's done. But I'll go with the fast forward at this point. That's now complete, cleaned up. The next step is going to be to wire up a single pulse such that if I hit the single pulse, it's debounced. That's going to be the monostable operation, and it's going to use the 555 that's located on the bottom half of this 556 chip. Since I had so much troubleshooting off in the wrong direction, I will probably save that for another video. Thank you for joining me. In the next video, I'm going to wire up the single step button, and hopefully I won't make a mistake. And I also have to test the 74LS04 inverter I have on the breadboard to make sure I didn't hurt it in today's endeavors. See you soon.